So we touched on negative powers in the last exercise. All right, we know, or hopefully from that exercise, a to the negative n is actually equal to 1 on a to the n, but n cannot equal 0. Okay, so if you have a to the 0, it's 1. Okay, remember that. Okay, you can't have negative 0 anyway, technically speaking. All right, so you can't. Oh, sorry, you can't have a as 0. Sorry, my mistake. Because 0 to the anything is 0, and you can't divide by 0. Okay, that's why that's there. There is another one. A to the 1 on n, so to the power of a fraction, is the nth root of a. Okay? Nth root of a. So if a is 1/2, it's the square root of a. Okay? So example, if a is to the half, that is equal to the square root of a. Yes, if a was to the power of a third, it would be the cube root of a. Okay? It's not really that hard. Okay, it's just a rule. Here we go. You ready for this one? This one is a bit more intense. A to the power of m on n. Okay. This goes through some steps. Okay. Is
well, I love the way you said steps is like
a to the 1 on n to the power of m. Can you see how that comes from one of the other index laws? Okay, you multiply them together, you get back there, don't you? So this is sort of working backwards through the index laws to try and make this as simple for you as possible. Alright? Which is equal to the nth root of a to the power of m. Okay, according to this rule here. If it's to the 1 on n, it's nth root a. Alright? Which is actually equal to the nth root of a to the power of n. Alright? So you can forget about these two middle ones. That's just showing you how it works. Okay, this is this. Okay, so if you come across this, it means this. Right? So, quite easy. Question 1. 6 to the negative 3. Express it with a positive index. So it's got to have a positive. We don't want the negative. What do I do? 1 over 6 to the 3. Alright, that's as easy as it gets. Right? As in 1c, yeah? So 3 to the 4 divided by 2 to the 3 to the negative 4. Right. What I would do here, there's again a couple of ways you can do it. What I would do, I would expand your bracket first. And the index law says we multiply these powers together. So you end up with 3 to the negative 16 on 2 to the negative 12. Now both are negative. That means flip. Okay, if the top one's negative, it goes on the bottom. Bottom one's negative, it goes on the top. Alright, so you end up with 2 to the 12 on 3 to the 16. Okay, so it's just using your index laws carefully yet again. I'll leave question 2 for you guys to do. Question 3, 9 to the half. Alright, it says evaluate without a calculator.
That'll be 3.
Why?
Because you have to square root 9.
Square root 9, which is 3. Alright, I wanted that in between step. So 9 to the half is square root 9, which is 3. Alright, what about a trickier one? 8 to the 2/3.
2.
Okay, if we go back to our rule, 8 to the 2/3, here it is here. Okay, the cube root of 8 squared. The cube root of 8 squared.
So it's 2.
Cube root of 64. What's something that multiplies by itself 3 times? 4 times 4 is 16 times 4 is? Okay, so it's actually 4. Okay, because 4 to the 3 is 64. Alright, so you can do them without a calculator. They do require your noggin switched on though. Okay?
What about 5?
That's what we're about to do, question 2. You want me to do the hardest question?
Yep.
Ah, you're a pest. I'll do one of the other ones first. Alright? Let's have a look at 5b. Okay? X to the 2/3 times x to the 1/6. Alright, what are you going to do? Well, no, I wouldn't. Alright, I don't know, but I wouldn't do that. I would do something else first. Alright, we need a positive index. We're simplifying to get a positive index. We're not even going to the root stage. Right, so you're going to what the indexes together?
Add them.
Add them. X to the 2/3 plus 1/6. Now, we can't add fractions with different denominators, so we've got to change this to a 4 on 6. So it's x's to the 5/6. Alright, and that's as far as you need to go. Alright? Now, let's go back and have a look at 5a. Square root 9 times the 3rd root of 81. Okay? What am I going to do here? Square root 9 times the 3rd root of 81. Alright?
Put it in
81.
fractional indices.
So I'm going to put it in fractional indices. So I'm going to get 9 to the half. I'm going to get 9 squared to the 3rd. Yeah? 9 squared, 81 is 9 squared. And we're cube root, so it's 1/3.
Yep.
Okay, so I'm going to combine these two now. So I leave 9 to the half as it was. And this is going to be times 9 to the 2/3. Alright, if you're going to simplify that, 9 to the half plus 2/3. Can't add those. So let's go for 6, 3/6, 4/6. So what is it?
7 and 6.
Alright, 9 to the 7/6. Okay. Which you can go even further, because what's 9? 3 squared to the 7/6.
And then, yeah.
I want to kill myself.
Let's not do H.
Which is 3 to the...
3 to y.
You get 14 over 6, which is 3 to the 7 over 3.
You think you're right, Matt?
That's 500 times
Darn.
Alright, because that's the final answer there. Sorry, I haven't done that very well. That's your final answer there.
Equation is too damn hard.
Alright, it's not too hard. Break it down into steps. This is what I keep telling you. Just break it down into steps.